Hey guys, so excuse me if I don't sound like myself. I am a bit stuffy today, but we're going to be going over the Module 3 study guide. So let's look at the first one, which has the graph, and you're supposed to find the average rate of change of g over the interval 4 to 5. So remember, g is the name of our function, not the output. G of x is our input, right? And then g of x is our output. Remember, g is the name, not the output, okay? All right, so average rate of change. It's kind of like constant rate of change. Remember, we do y2 minus y1 over x2 minus x1. Just because this was on the test doesn't mean you get to forget it. You need to remember this, right? Cool. So change, right? Delta of the output over the change in the input. So for later, you can think of this as g of x 2 minus g of x 1 over x2 minus x1. Doesn't matter what the variable is, right? So if this was g of w, right? Don't freak out. W is our input, so g of w is our output. W2 minus W1. Okay, that doesn't matter too much for this problem, but it'll come helpful in other problems such as number 2. Okay, so I'm not going to draw out the graph. You can see it, but I'm going to draw a rough sketch. I lied. Okay, so we're going on the interval 4 to 5. So this is the interval of our input. So we can already, we can already find the change in the input, right? So this is our final, this is our initial. So we're going to do 5 minus 4, right? Not 4 minus 5, we're going 5 minus 4, because we're starting here, ending here. Initial, final. Okay, so on the graph, it does something like that, right? So we say, okay, 4 is here, 5 is here. So I obviously drew this kind of wrong, excuse me. But the point at 4 is 4, let me see, 1.6. Okay. And then our point at 5 is 5, 6.8. Okay. So what do you think is going to go on the top? I feel like Dora the Explorer, waiting for you for an answer. That is correct! This is our final output. This is our initial output, right? So we're going to do 6.8 minus 1.6. This is g of 5, and this is g of 4. So something you could do to check your answer to make sure you don't switch. This should be a point, and this should be a point. This is the point 5, 6.8, right here. This is the point for 1.6, right here. Okay? And then if we plug this into our calculator, we should get the correct answer. Okay? I don't have a calculator on me right now, and I'm doing this before I head to work, so this is going to be kind of a quickie video. Right? Make sense? Yay! Okay. So, as a reminder, for whatever function you have, if she says over the interval -1 to 10, right, we can find our change in the input, which is final minus initial. 10 minus -1. If it was on the interval 10 to -1, right, this is still our final, this is our initial, even though this is smaller. So we do -1 minus 10. Okay? But for right now, we're not going to do that. But just good to know. Okay, so this is our function h, right? So we would find, let's say this is -1, and This is negative 10. Okay. So this is the height, right? Is the output of our function. So it would be negative 1 h of negative 1, whatever this may be. This would be 10 h of 10. Ooh. Okay. So change in the output. So this is our final point. So we need our final output. Ooh. H of 10. Okay. Minus h of negative 1. Okay. So this is how you do average rate of change given a graph. Cool. So that kind of goes over number 1. So let's move on to number 2. So the function shown is a projectile equation. Projectile equation, you don't really need to know about that. That's just words to make sure you know to focus on what's important. So h of t is the height. H is not the height. H of t is the height. Correct? At t seconds. So seconds is a unit of time, right? So this is time in seconds. So h of t equals negative 16t squared plus 64t. Okay? And it's just saying that the height is in feet. So calculate delta h over delta t over the interval 2, 4. Okay. So I'll give you a second to think about how we should start this problem. Since this is a video, even if I don't say, okay guys, think about this for a second, feel free to pause the video and try to work out problems on your own, because that's going to really help you out. Okay, so what values are these? Are these t or are they h of t? They are t, okay? So we can already find delta t, yeah? Okay, so delta t is final minus initial, so 4 minus 2. So now we need to find the output, right? We find the output by plugging in these inputs into our function. So up here, it should be the output, the final output, right? Using the final input minus the initial input using the initial output using the initial input. Okay, so how do we figure this out? Great, we just plug it in to our function. So first let's figure out what h of 4 is. So h of 4, notice this was h of t before. So wherever we see a t, we're going to plug in a 4. So that means 16, we see a t, so we're going to do 4 squared. Notice I'm not doing 16 squared, right? The exponent only affects whatever is right next to it. So that's the difference between, let's say, 16t squared and 16t squared. I know it sounds the same, but see how this exponent is now affecting everything that's next to it? So in this case, we would square 16. But this 2 is just pointing to t. So we're not going to worry about squaring that. Okay? So, back to this. We have 16t squared, but we're not done yet. We need to add 64t. So 64, we see a t, so we're going to plug in 4. So like I said, you guys are going to need to do the calculations for these. All right, so we have h of 4, right? So let's just call this number, I don't know, A. Now we need to find h of 2. So 16, we see a t, so we're going to plug in a 2, plus 64t, our t is 2. We plug it into our calculator, we get a number, and I'm going to call this b. So now we plug in whatever numbers we got in our calculator back to this function. Okay? So h of 4, we plugged it in, we got some number, called it a. h of 2, got some number, called it b. All over 4 minus 2. So once you plug that into your calculator, you'll get a final answer. Okay? So hopefully that makes sense. I'm gonna talk real quick about another way you might see this problem. So let me clear this. Where is my delete button? There you are. Okay. So let h be a function that defines the height in terms of the number of seconds t. The rule for this function is 16t squared plus 64t. What is the average rate of change of the height as the number of seconds increases from, what was our interval, 2 to 4? Oh, I already forgot. 2 to 4, okay. So that might seem like a crazy problem, but it is the exact same thing that we've done. So let's take it piece by piece. So let h be a function. That is our name. That defines the height. Whatever it's defining is our output. So this is our output. In terms of, so where we see in terms of, with respect to, given, all that stuff, whatever follows is our input. Okay? So we know that our output is the height. So I'm just going to write height here. Okay? Our name is h, so we're going to put that here. And then number of seconds, t, is our input. So I'm going to put number of seconds here, and then I'm going to put t on the bottom. Okay? Equals, so we have our name, our input, all of this is the output, and we know that the output is height. So the only thing that's missing is the rule, and luckily they gave us that. 16t squared plus 64t. Okay. What is the average rate of change? You need to remember that the average rate of change is the change in the output over the change in the input. So our output is height, so the change in height over the change in the input, which is time. As the number of seconds increases from 2 to 4. So when you see stuff like increases or decreases, that's a change, right? We're going from one number to another, whether we're going up, increasing, or down, decreasing. So we're increasing from 2 to 4. We're starting at 2, so that's our initial. We're ending at 4, so that is our final. Okay, so same thing that we did before. 2 to 4 is our number of seconds. That's our input. So our final input is 4. Our initial input is 2. 4 minus 2. This looks familiar. It is the same exact thing that we did before. Change in the height. How do we find the height? How do we find the output? By plugging in our input to the h function. So h of 4, right? Because 4 is our final input, minus h of 2. And then we can figure this out by doing everything we did in the last problem. Make sense? So you might see something like that later. So know that it's the same thing.